Okay, here's another example program to kind of tie everything together. This is what we're doing. Einstein's E equals mc squared formula. Energy equals mass in kilograms times speed of light squared. So we can do that in our program. So let me just run the demo for you. Let's say we have a 150 pound person, and we're just going to enter that weight, and our output says at 150 pounds your total annihilation will yield 6.13 times 10 to the 18 joules of pure energy. Okay, remember the E notation. You can think of E as times 10 to the. Okay, so let's take a look at the code. It is pretty straightforward. I've created some variables. I just use doubles for the weight in pounds, and then we're going to have to convert the user's weight to kilograms after he or she enters the weight. So I have another variable to hold the weight in kilograms, and then a variable which I've called E, which is the famous E for energy in the formula. And for the speed of light, I looked this up on Google. I used an integer. It's in the millions, so I can use just a regular integer. I don't have to go with a long integer or anything. And I made it a const because that is a predefined constant. That is not going to change. So we plug that number into that variable one time at the beginning of the program, and then I don't have to type that long, ugly number anymore from that point forward. Okay, so let's see. We are prompting the user to enter the weight in pounds. Once I have the weight in pounds, I'll convert the pounds to kilos by dividing by a constant of 2.2. And finally, just plug it into the formula. Energy equals mass in kilos times the speed of light squared, which I'm using the POW function that we've talked about before. I could have done speed of light times speed of light as well. That would have worked just fine. Now, I only did, I was playing around with the precision flags in this case. I didn't go with our usual syntax. I'll show you. I just went with set precision, and I'm going to tell you why. Because in this, well, I'm going to uncomment that and then comment out the one that I was using. Let's run this again and look at the kind of output we get. Okay, so same input here. I'll say a 150 pound person. Okay, so when I do the show point, for one thing, I'm going to get a decimal point, even if I don't, we don't care about fractional pounds. The user doesn't care. I really don't need to display this decimal here. And the show point is doing that, okay? So that's one reason why you wouldn't want the show point. And then the fixed is going to prevent your program from using E notation. And normally that's a good thing, but I think in a program like this, we want E notation because this number in joules is so enormous. It's almost illegible like this. It's much easier to read it in scientific notation or E notation. So that's why I decided not to use the fixed or the show point in this case. So there we go. I'll bring that back. And there you have it. So then the output is pretty basic, doing a lot of cascading with the insertion operator here and just constructing the output one piece at a time. And yeah, I did throw in a new line here to kind of break it up a little bit. And another thing I will mention, and your book probably uses this technique a lot, you don't have to do a separate set, especially like in this case where I only have the set precision. I don't have like this long spiel here. You could just do something like this. So I could forget about this line, and then you can just drop your set precision into the right into the output stream before, of course, you print out the energy. You don't have to do it in a separate line like I've been doing it in previous videos. So you have some options there, just as long as you get that into the output stream one way or another before you print the energy in this case, and that'll work. Okay.